Okay, next is odds ratio. Odds ratio has some theory in it. Odds of an event A tells you how much likely it is that event A occurs than it is that event A does not occur. So probability of A divided by probability of A complement, that is going to be probability of A upon 1 minus probability of A. So for example, if probability of A is 2 by 3, then it becomes 2 by 3 upon 1 minus 2 by 3, or 2 by 3 upon 1 upon 3, or 2 upon 3 and 3 upon 3 into 1, that is equal to 2. So now a hypothesis H that is true with the probability of PH, and a new evidence E is introduced. So there is a hypothesis H that is true with a probability of P, so PH, and a new evidence E is introduced. Now we want to know conditional probability given the evidence E that H is true and that H is not true. So the probability of H giving the evidence will be probability of evidence and H divided by probability of evidence. So probability but probability of evidence giving the hypothesis is probability of evidence and hypothesis given by probability of hypothesis. Thus probability of hypothesis and evidence is equal to probability of, because these two are the same, then probability of H given E is the same probability of H given E is the same as probability of E given H times probability of H. Same is with probability of H complement given E will be the same as probability of evidence given H complement times probability of H complement. So when we are calculating the new odds as the new evidence is introduced, is basically this divided by this, which is this all divided by this all. So new value of odds of H is, which is the old value of H multiplied by the conditional value of the conditional probability of the evidence given H is true divided by the conditional probability of evidence given H is true divided by the conditional probability of evidence given H is not true. Thus the odds and thus the probability of H increases whenever the new evidence is more likely when the H is true than when H is false, right? So the old knowledge was that the odds were probability of H upon probability of H complement, or probability of, this was the old. But then with the new evidence is produced, which is the new odds ratio, this one, then you are multiplying it by probability that the evidence when the hypothesis is true divided by the probability of evidence when the hypothesis is not true. So if the evidence is more likely than the hypothesis is true, then this probability will be higher, and that is why the odds ratio will go up. We'll do with a simple example. And the example is an urn contains two type A coins and one type B coin. When type A coin is flipped, that the head comes with a probability of 1 by 4. When type B coin is flipped, the head comes with a probability of 3 by 4. A coin is chosen randomly from urn and flipped. Given that flip landed on the head, so we know this, that given that flip landed on head, what is probability that it was a type A coin? So we start with a probability tree here. We have a type A coin and a type B coin, and we don't know which is what or how many of them are there, because there are we know that they have two type A coins and one type B coin. So the probability of type A coin is 2 by 3 and type B coin is 1 by 3. And now when you flip a type A coin, you get a head with a probability of 1 by 4, and you get a tail with a probability of 3 by 4. And with type B coin, the head is going to be 3 by 4 and the tail is going to be 1 by 4. Now what is the probability that it was A type? So we have this new evidence. Given that the flip landed on the head, what is the probability that it was a type A coin? Okay, so we calculate the odds ratio. Let A be the event that A was flipped. Okay, so let's say let A is the event that A was flipped, and B is going to be A complement, because you are only if you are flipping A or B, and we want to know is probability of A, knowing that you get a head. So probability of A, knowing that you have a head, divided by probability of A complement divided by you got a head, is going to be probability of A divided by probability of A complement multiplied by probability of head, knowing that it's an A, probability of head, knowing that it's a complement. So we can get this as probability of A is 2 by 3 and probability of A complement is 1 by 3, and probability of head, knowing that it's an A, we know that it is 1 by 4, and probability of head, knowing that it's A complement is 3 by 4. So we can get it as 2 by 3. So now we get that we have the odds is 2 by 3. We only know the odds of A giving head. So we know the odds of A given head is 2. But that doesn't give me the probability. What we are asking is the probability. Calculate the probability that what is the probability that it was a type A coin. So now we have to go further. We know that the probability of A giving head divided by probability of A complement giving head is 2 by 3. But since there are only 2 coins, probability of A plus probability of A complement is going to be 1, or probability of A complement is going to be 1 minus probability of A. So probability of A divided by 1 minus probability of A is going to be 2 by 3, and you can solve this to get the probability of A to be 2 by 5.